All right, we are recording. So continuing my code walkthrough of the updateElements method here, I have an array list that contains the fading enemy sprites, and these can be either the tornado graphics or the gem graphics. Let's see. I update each one. I call the update method on each fading enemy sprite. It calls return true if destroyable, so I'm checking that with this if statement. And basically, if you're inside this block, that means, okay, we can remove this fading enemy sprite now. And if we aren't using the tornado graphic, that means it's a gem enemy, and that means that as soon as the fading enemy sprite, like it's one of those imploding gem enemy sprites, as soon as the implosion graphic is done, then we need an explosion of gemstones. This is the code that makes that happen, and depending on what type of enemy, then we spawn different types of gems. For instance, stationary here, that's the red enemy. We spawn 4 ruby squares, and basically we get random integers for the vector of the item. And here's the gravity. And we've got the item image manager, which basically converts this constant here into an image. Obviously, I'm going to have to do a lot of changes when it's time for me to add custom items to the game. I'm going to do that eventually, but not at this point. Then there's the enemy that moves left to right. That's gray if it's a tornado enemy, and pink if it's a gem enemy. So I have the 4 different directions: northwest, northeast, southwest, southeast for the pink agates. The enemy that moves up and down is what I call float peridot. Yeah, I tried to come up with snappy names for each of them. This is rough ruby, patrol agate, float peridot, and I know what you Steven Universe fans are thinking. It's peridot, not peridot. Either pronunciation is legitimate. The lightning enemy, that's the yellow one, so we've got... actually, I'm really proud of the name I came up with this one. Zappo Topaz. It's a palindrome. There's 4 prisms, and then there's one that has its point facing down. Turret, which is basically the non-moving enemy that can shoot at you. That's Spark Sapphire. There's 4 sapphire boxes, a point left and a point right. Up-down turret, that's the enemy that moves up and down and can fire at you. That's Blast Amethyst. There's 4 round amethysts. There's 2 amethysts, which are squares that are sort of tilted 45 degrees. I'm using the word kite for those. There's one that points left and one that points right. I think this is pretty appropriate. I think Blast Amethyst is the most dangerous enemy that I've got, and that one having 8 gems instead of most of the other ones, which have only 4 or 5, is pretty appropriate. The fireball turret just sits there, but it can shoot bouncing fireballs. At first I was going to have a bunch of out-of-the-box enemies, but then I realized it would be a little bit better if I went with the custom NPC system so players could make their own. Obviously, I'm still working on the custom NPC system, but I guess that's for another time. Since we're in this code block, regardless of whether we spawn items or not, we can remove the fading enemies. We can remove the fading enemy sprite from the list. We decrement I because basically we'd otherwise skip an item if we didn't. Okay, so now we're into a part where I guess we're not updating the enemies. This is where we do collision detection between enemies and bullets that the player has fired. If it's not a bullet that the player has fired, then we just skip that one. And obviously here it's a nested for loop. We're going through all the enemies, and for each enemy we also go through the list of all bullets. And if the bullet's collision rectangle hits the enemy collision rectangle, we remove the bullet, decrement J, which is the inner index here. And let's see. Oh yes. If the enemy has taken enough damage to kill the enemy, then we remove the enemy from this list, decrement I, because that's the outer one. If the enemy uses a tornado graphic, then we create a fading enemy sprite. And we also have which direction the enemy is facing. Tornado graphics actually pay attention to which direction the enemy is facing. Gem graphics do not. So this is the one for the gem graphics. And also here, we check to see whether the bullet should spawn a heart or whether rarity, which is basically the default player character sets rarity, if rarity fired it or if it should spawn a heart. This is the customized playable character code. Then we create a new heart at exactly the place where the enemy died and add that to the array list of items. Then we have something very similar here for updating the rainbow elemental out-of-the-box boss. Ideally, I'd like to get the custom NPC system to the point where you can create better enemies than this, or I should say better bosses than this with their own attacks, but that's a ways off. First, we straight up call the update method on the boss sprite, and if the boss sprite is alive, then oh wait, I see. If we've just killed the boss sprite, then we create a checkpoint flag. It's a boss checkpoint flag, which behaves a little bit differently from a regular one in that getting this one essentially tells the game under the hood, hey, as soon as you respawn here, do not cause the boss to spawn. And then we set boss sprite to null, which is the equivalent of removing it from a list, except we don't have a list of boss sprites. There's only one allowed per room. If the boss sprite is visible, then we perform collision detection with the bullets much the same way we did with enemies, tell it to take damage. Then we do collision detection between items and the player. If it's a heart, then we tell the player to heal and remove the item. And we add a collected item sprite. That essentially is a caption here for plus life in the case of hearts. For checkpoint flags, actually we have a whole different method for that, which probably I should be recalling here, but I must not have thought of it. Pretty much every other item that we've got, we just add something to the collected item sprites, which uses the same images that whatever the collected item was, or I should say whatever the former item was, now that it's become a collected item. Remove the item from the list, decrement I, go from there. Then we update all the foreground widgets. If it's a smart widget sprite, then we also pass in whether it's raining and the event flags. Otherwise, regular widgets we just call the update method, which pretty much just moves the animation forward. Let's see what time I've got. Oh, I got plenty of time. Then we update all the background parallax layers. It's a little bit strange that first we update the foreground widgets, then we update the parallax layers, then we update the background widgets. But oh well. Pretty much what this method does is it calls the update method on all the widgets and smart widgets that are on the parallax layer. Then we have the hurt zone update method, and for a recap, hurt zones are the lightning hazards that you could appear. Hurt zones are the lightning hazards which you could see at various places in the factory. That gets updated as well. And that's pretty much the end of the updateElements method. Obviously, each element has its own version of the update method, and each game element has different things to think about. Hurt zones have to ask the question, should I shoot out lightning now or should I not? Is it too soon to shoot out lightning? These widgets, especially smart widgets, they have to ask, okay, do I need to react to the fact that the weather has changed? Do I need to react to the fact that an event flag has changed? That kind of thing. There's all kinds of other stuff in the update method that performs the calculations needed to actually make the game work, and that's what that's essentially what happens in the update method.